In Peru, approximately 300,000 people work in artisanal and small-scale gold mining in 25 regions throughout the country. While the use of mercury is common in gold processing, currently in regions such as Puno or Arequipa, gravimetric plants are used to recover gold without mercury. Alluvial gold mining is practiced in the Puno region. The gold ore is extracted from the mining face with heavy machinery to be transported to the washing area. On the other hand, in the Arequipa region, underground or vein mining is carried out. In this type of mining, tunnels and galleries are excavated to access the minerals below the surface. The gold ore is extracted by pulleys and mining cars and then transported to the processing plant. Now let's explore the technology used in the fluvial-glacial mining developed in Puno. In this type of mining, ore processing starts with a channel sample where the gold ore is concentrated together with gravel and grit. Heavy materials sink and become trapped in mats, while lighter materials are washed out by the water current. The concentrated material remaining in the mats is taken to a gravimetric plant, where it is processed with a vibrating shaker. The pre-concentrated ore is separated, removing gravels and fine gravels larger than 2 millimeters, and then passed to an agitation tank to form the pulp. In the case of underground mining, processing begins with the crusher, which reduces the size of the ore extracted from the pit and then passes to the mill. The ore is then passed to the ball mill, whose function is to liberate the gold. It is recommended that the ore be up to 106 microns in size and pass through 140 mesh for best results. In both alluvial and underground mining, an agitation tank is used. This tank homogenizes the ore pulp and separates the materials that are not of interest, thus reducing the volume that will enter the gravimetric table. It works by means of a vortex-like motion generated by a shaft attached to paddles that allow the movement of the pulp, separating the gold-rich material by weight and lifting the tailings to be removed. To regulate the intensity of the movement, it has a frequency regulator and also has a reduction box that provides additional force. The gravimetric table takes advantage of the physical properties of the minerals to perform selective separations and obtain gold, as well as reject the material. It vibrates longitudinally, which causes the mineral particles to be slowly dragged along the deck, while the gold, due to its greater weight, is trapped in the different riffles on the gravimetric table. Next, we move to the recirculation tank, which stores the water coming from the gravimetric table and also serves as a power source for the table by means of a water pump. This creates a closed circuit that improves water utilization, which can be reused and only needs to be changed every 20 days.
In addition, it receives the 4 ports of the gravimetric table, where in 3 of them the sterile black grit from the concentrate is received, and port 1 receives the concentrate of grit with the presence of some traces of gold that may have escaped to the table.
And so, with this innovative and efficient process, the gold retained on the gravimetric table is taken to the final stage, smelting and obtaining gold ingots or bars. This system, which achieves an average gold recovery efficiency of 90%, demonstrates that the use of mercury is not necessary. Our virtual visit has allowed us to learn a little more about environmentally responsible practices in small-scale and artisanal mining. We appreciate your participation and hope you enjoyed this awesome experience.